How is a compass made?
A compass is a magnetized metallic pointer that can rotate about a low-friction pivot point. Sometimes the pointer is placed in a container of liquid to dampen the movement of the pointer. The magnetic pointer aligns itself with the north/south orientation of Earth's magnetic field. And the person using the compass can determine what direction he or she is headed by looking at the pointer.
What does it mean to say that an object is static?
Static means not moving. In the fields of engineering and physics, to be static means that the object does not move. When static, all the forces acting on a body must sum to zero. That is, the net force on the body is zero, so the object does not move.
What is a coulomb?
Equal to the charge of 6.24 x 1018 electrons, negative, or protons, positive.
What is saturation?
Extent to which other wavelengths of light are present in a particular color.
What is a tsunami?
Series of waves in water caused by underwater earthquakes and volcanic eruptions.
What are some typical power outputs?
The following table was adapted from Wikipedia's entry on orders of magnitude, power. Retrieved on November 13, 2009. Unit example *femto-watt, 10 to 15 watt, 10 FW, approximate lower limit of power. Reception of digital cell phones picowatt, 10 to 12 watt, 1 PW, average power consumption of a human cell microwatt. 10 to 6 watt, 1 carat W, approximate consumption of a quartz wristwatch milliwatt, 10 to 3 watt. 5 to 10 MW, laser in a DVD player watt, 20 to 40 W, approximate power consumption of the human brain. 70 to 100 W, approximate basal metabolic rate used by the human body. 5 to 253 W, per capita average power. Use of the world in 2001. 500 W, power output of a person working hard physically. 909 W, peak output power of a healthy human. Non-athlete, during a 30-second cycle sprint kilowatt, 103 watts, I. 366 kilowatts, power received from the Sun at Earth's orbit by 1 square meter up. To 2 kilowatts, approximate short-time power output of sprinting professional cyclists. 1 kilowatt to 2 kilowatts, rate of heat output of a domestic electric tea kettle. 2 4 kilowatts, average power consumption per person in the United States as of 2009 40 kilowatts to 200 kilowatts, approximate. Range of power output of typical automobiles megawatt, 106 watts, 1.5 MW, peak power output of a wind turbine 2.5 MW, peak power output of a blue whale 3 MW, mechanical power output of a diesel locomotive 16 MW, rate at which a typical gasoline pump transfers chemical energy to a vehicle 140 MW, average power consumption of a Boeing 747 jumbo jet 200 to 500 MW, electrical power output of a typical nuclear power plant gigawatt 109 watts, 2.074 GW, peak power generation of Hoover Dam 4.116 GW, installed capacity the world's largest coal-fired power plant 18.3 GW, current electrical power generation of China's Three Gorges Dam. The world's largest hydroelectric power plant terawatt, 1012 watts. 3.34 TW, average total power consumption of the United States in 2005 50 to 200 TW, rate of heat energy release by a hurricane petawatt. 1015 watts, 4 PW, estimated total heat flux transported by Earth's atmosphere and ocean away from the equator towards the poles 174.0 PW, total power received by Earth from the Sun yottawatt, 1024 watts, 384.
What is a kilowatt hour? Kilowatt hour.
Unit of energy used to measure electrical energy.
What is a half-life? When will a particular radioactive nucleus decay?
It's impossible to know. All that can be known is the average time between formation and decay. And we know that the number of decays will be proportional to the number of nuclei present. Now, suppose we start with a large number of nuclei. In a given time interval, say 1 second, a certain number will decay. At the end of that second the number of nuclei that haven't decayed will be smaller. So in the next second there will be fewer decays. At some time there will be only half as many decays in a second as there were originally. That time is called the half-life. One half-life later there will be only V4 as many decays as at the beginning. After another half-life there will be half again as many, or 1/8 the number of initial decays.
Why do physicists believe that there are particles inside protons and neutrons?
Ernest Rutherford, 1871 to 1937, scattered alpha particles off gold atoms and discovered that the atom was not filled with a uniform positive material. In the same way, scattering of protons at high energies off hydrogen nuclei showed that the proton is not composed of uniform positive material. Rather, it is composed of three much smaller charged particles called quarks. The neutron is also composed of three quarks.
What is the compressive force?
Force pushing an object together.
What is the second law of thermodynamics?
In the early 1800s, many scientists and engineers worked to improve the efficiency of steam engines. The French military engineer and physicist Sidi Carnot, 1796 to 1832, tried to answer two questions. Is there any limit to the amount of work available from a heat source? And can you increase the efficiency by replacing steam with another fluid or gas? Carnot wrote a book in 1824 called Reflections on the Motive Power of Fire that was aimed at a popular audience, using a minimum of mathematics. The most important part of the book was the presentation of an idealized engine. This engine could be used to understand the ideas that can be applied to all heat engines. A heat engine is a device that converts heat into work in a cyclical process. That is, the engine periodically returns to its starting point. A steam engine, gasoline, or diesel power automobile engine are all heat engines where the pistons return to their starting positions. A rocket is not a cyclic heat engine. A diagram of Carnot's simplified model allowed him to give answers to his two questions. He found that the efficiency, that is, the work output divided by the heat input, depended only on the temperatures at which heat enters and leaves the system, or efficiency equals, thought, cold/thought. It doesn't depend on the fluid or gas used in the engine. Real engines would have lower efficiencies, but no engine could have a higher efficiency. A simplified version of the second law according to Carnot is that it is impossible to convert heat completely into work in a cyclic heat engine. There is always some heat output. Note that the first law would allow a heat engine to have no heat output. The heat input would equal the work done. The second law can be shown in the diagram below, where the input heat is taken from a reservoir that maintains a constant high temperature and the output goes to a second reservoir at a constant low temperature. For example, a steam turbine gets its heat from high temperature steam and puts its output heat into a much colder lake or river. This turbine plant in California uses natural gas to heat water into steam that then produces energy in the turbines that generate electricity. Not all the energy from the natural gas can be converted to electricity, and lost energy escapes as heat. Carnot's model engine is reversible. That is, it can be run backwards, which is impossible for a real engine. Thus all real engines are less efficient than the ideal one. Friction also lowers the efficiency of real engines. The second law, according to Carnot, means that there is no such thing as a perpetual motion machine. Although such a machine could obey the law of conservation of energy. The heat it puts out means that the machine would eventually stop. Carnot died in a cholera epidemic at age 36. Because people were concerned with the transmission of this deadly disease. All his papers and books were buried with him after his death. Thus only a few of his works have survived. Despite the limitations of Carnot's model, his work inspired Rudolf Diesel, 1858–1913. To design the engine named after him to achieve higher efficiencies than steam engines. So, Carnot's book was important to the design of practical engines. A second version of the second law can be stated as heat doesn't flow from cold to hot without work input. For example, a refrigerator removes heat from the food at a low temperature and outputs heat from the coils in the bottom or back of the refrigerator. It will not move the heat from cold to hot, however, without a motor doing work on the circulating gas.
How did Einstein describe the gravitational field?
Einstein in his general theory of relativity showed that the gravitational field was actually a distortion of space-time caused by the mass of the object. Because space-time has 4 dimensions that are very difficult to visualize. The distortion is best seen with a 2-dimensional model. Often the model consists of a rubber sheet in which a bowling ball is placed, see illustration on page 39. The sheet is pulled down by the ball, which represents the sun. Earth is a tiny ball that is placed on the sheet and given a push perpendicular to the direction of the sun. This ball orbits the sun a few times until friction causes it to speed up and spiral into the sun. In the words of physicist John Wheeler, space-time grips mass, telling it how to move. Mass grips space-time, telling it how to curve.
What is mathematical physics?
Study of how physical processes can best be described by mathematics.
What is the universal gravitational constant?
Proportionality between gravitational force between 2 objects and gmm/r2.
What is a real image?
A concave mirror or a convex lens can redirect light from an object so that it does converge to a single point. That point is a real image. It is in front of a concave mirror and on the other side of a convex lens from the object. If you place a screen, piece of paper, or wall at the location of the image, you'll see it on that surface.
How far away can FM and AM stations be received?
All electromagnetic waves travel in a straight line while in a uniform medium such as the lower atmosphere. Therefore, most radio waves only have what is called a line-of-sight range. That means that if a mountain range or the curvature of Earth were in the way of the radio signal, the receiver would be out of range and would not receive the signal. This is why most broadcasting antennae are placed on tall buildings or mountains to help increase the line-of-sight range. Waves with frequencies below about 30 MHz are able to reflect off the charged particles in Earth's ionosphere. This is referred to as skip. Instead of passing through the ionosphere and entering space as higher frequency electromagnetic waves do, the lower frequencies on the AM band can be reflected back toward Earth to increase their range dramatically. After sunset, the ionosphere's altitude permits stations to be heard thousands of kilometers from a transmitting tower. A handful of AM stations are clear channel stations. That is, there is only one station in the continental United States broadcasting on that frequency. Those stations can be heard across almost the entire country without interference from other stations. Broadcast FM stations, with frequencies 88 to 108 MHz, penetrate the ionosphere, and so can only be heard 80 to 160 kilometers from the transmitter.
Why do most color inkjet printers use 4 colors to print, instead of the 3 primary colors for subtractive color mixing?
It would seem that a color inkjet printer mixing the 3 primary pigments of yellow, magenta, and cyan should be able to produce all the other colors, including black. When all 3 primary colors are combined, however, the mix looks more like a muddy brown color than black. Although these are the primary colors of which other shades can be created, they do not represent all the colors of the spectrum needed to form black. That is, there are gaps in the wavelengths that these pigments absorb. Therefore, most color inkjet printers have a cartridge with yellow, cyan, and magenta ink, and another separate ink cartridge of just black.
What is a magnetic field?
Region around a magnet that causes forces on magnetic materials or other magnets.
When and where will there be total solar eclipses over the next few decades?
The following map shows the date and location of total solar eclipses that took place from 2001 to 2010, as well as those that will take place into the year 2020. The last total solar eclipse in the United States was seen on February 26, 1979.
What is a qubit?
Qubit is short for quantum bit, the basic piece of information for a quantum computer. A qubit can be the state of an atom, ion, photon, or an electron. As was the case of the polarization of the two gammas, the qubit doesn't have a value of 0 or 1, but is in a state that is a superposition of 0 and 1, so it can have any value between those two numbers. If you try to measure the value of the qubit, you will get either 0 or 1. So it will act like a bit in a normal computer. The trick is to use one of two entangled photons, or atoms, to determine the qubit state without collapsing it into either 0 or 1. Quantum computers are by nature parallel machines that can work on many problems at once. At this time, computers with 12 qubits have been demonstrated. So there is a long way to go before such a device is practical. Still, progress is being made. A company has demonstrated a way of using the kind of chip lasers used in CD players to create entangled photons, greatly reducing the size, complexity, and cost of a quantum computer.
What is needed to create a circuit?
A circuit is a circular path through which charge can flow. So, the first requirement is a complete, unbroken conducting path. Second, there must be a source of potential difference, most often a battery. The battery provides the voltage that will produce the current in the circuit. With only a battery and wire connecting the two ends of the battery, the resistance in the circuit will be almost zero, and the amount of current will be very high. This situation is called a short circuit. The wire will become hot enough to burn you. So, for a useful circuit, there must be a third element, a device with resistance. This may be a resistor, lamp, motor, etc. In terms of energy, the energy input to the circuit is the chemical energy stored in the battery. When the circuit is complete, the chemical energy becomes electrical energy in the wires. That energy is then converted to thermal energy in the resistor or lamp, or kinetic energy in the motor. The hot resistor or lamp then radiates heat and light into the environment. In our households, the battery is replaced by the electric generating station operated by the utility company. It may use the chemical energy in fossil fuels such as coal, oil, or natural gas to boil water, i.e. produce thermal energy. The steam from the boiling water then turns the generator, converting the energy to rotational kinetic energy. The generator then converts this energy of rotation into the electrical energy that is transmitted to the home. A nuclear power plant uses the nuclear energy in the nucleus of the uranium atoms to heat the water and produce steam. From that point on, the nuclear and fossil fuel power plants are essentially the same.
What is a thermostat?
A device that is part of a system that maintains a constant temperature.
Who were the first physicists?
Although physics was not considered a distinct field of science until the early 19th century, people have been studying the motion, energy, and forces that are at play in the universe for thousands of years. The earliest documented accounts of serious thought toward physics, specifically the motion of the planets, dates back to the years of the Chinese, Indians, Egyptians, Mesoamericans, and the Babylonians. The Greek philosophers Plato and Aristotle analyzed the motion of objects, but did not perform experiments to prove or disprove their ideas.
How does Einstein's special theory of relativity affect momentum?
The same factor, y, that affected distance and time, affects momentum in the same way, that is, relativistic momentum is ymv. Gamma is 1 at slow speeds and becomes large only when the velocity is near the speed of light.
What is the focal length of a lens?
The focal length measures the strength of a lens. Consider a converging lens. Rays from a very distant object come together at the focal point. The focal length is the distance from the lens to the focal point. Lenses with very convex surfaces have shorter focal lengths, while flatter lenses have longer focal lengths. For diverging lenses, the focal point is virtual. That is, it is the point from which the diverging rays leaving the lens would have come from if a point object were placed there.
Where is the center of gravity of a person?
The center of gravity of a person depends on how that person's weight is distributed. The distribution is typically different in adult males and females. Males have more upper body mass while females have more mass in the hip region. A male's center of gravity is about 65% of his height, while that for a female is about 55%. Try this. Stand facing a wall with your toes against the wall. Now try to rise to stand on your toes.
Where can resonance be found on the playground?
Children discover resonance early in life. When playing on swings, they use their arms and legs to pump themselves back and forth on the swing. They recognize that if they pull back on the chains every time the swing is at its largest backward displacement, they will achieve the largest amplitude. If, however, the pull back at other times, or if a parent pushes at the wrong time, the amplitude will be decreased because the external frequency isn't at the natural frequency.
What's the strength of gravitational fields of other astronomical objects?
This table shows the properties of the Sun, planets, and Earth's moon. It also shows the strength of the Sun's gravitational field at each planet, and the strength of the planets' gravitational fields at their surfaces. The Sun and Jupiter, Saturn, Uranus, and Neptune are gaseous and have no solid surfaces.
How does force affect acceleration?
From your explorations you could draw the conclusion that when there is only one force exerted on an object, the larger the force, the larger the acceleration.
What is an electroscope?
An electroscope is a device used to measure the charge on an object. It consists of two metal leaves, either thin aluminum foil or gold leaf, attached to a metal rod. If you touch a charged object to the metal rod, the two leaves will be charged with like charges, and so they will repel each other. The larger the charge, the greater the angle will be between the leaves.
What is antimatter?
In 1932, Carl Anderson, 1905 to 1991, was studying particles produced when cosmic rays struck lead sheets in a cloud chamber that was in a magnetic field. He found low-mass particles that curved the opposite direction from electrons, showing that they had positive charge. He later confirmed the existence of these particles by using a laboratory source of high-energy gamma rays. This positive electron was named the positron and was the first form of antimatter found. Anderson shared the 1936 Nobel Prize for his discovery. When a gamma ray with sufficient energy strikes matter, it can produce an electron-positron pair. Energy is converted into particles with mass. The minimal amount of gamma ray energy needed is given by Einstein's famous equation. A gamma equals melectron 2 plus positron 2. The unchanged arc gamma produces a negatively charged electron and a positively charged positron, so electric charge is conserved. Positrons are also emitted in radioactive decay of isotopes that have a deficit of neutrons. For example, stable carbon exists as 12C or 13C, 6 protons and either 6 or 7 neutrons. As was discussed above, 14C decays by emitting an electron. One of the neutrons changes to a proton with the emission of the electron and antineutrino. On the other hand, 11C, with only 5 neutrons, is a positron emitter. One of the protons changes to a neutron with the emission of a positron and a neutrino. When a positron strikes matter, the positron and an electron annihilate each other, producing 2 or 3 gammas. Particles with mass are converted to energy.
What is the zeroth law of thermodynamics?
If objects A and B are in equilibrium and B and C are in equilibrium, then A and C are also in equilibrium.
How does gravity fit into the Standard Model?
It does not fit. Gravity, explained by Einstein's general theory of relativity, is extremely successful on the macroscopic scale. But, all attempts to create a quantum gravity have failed. So have attempts to fit gravity into the Standard Model.
What is black?
The absence or the absorption of all light.
What is the middle ear?
Between outer and inner ear. Includes the eardrum, the hammer, anvil, and stirrup. The 3 smallest bones in the human body, and the oval window on the inner ear.
How is a wheel and axle similar to a lever? What is a wheel and axle?
It consists of a disc, the wheel, attached to a thin rod, the axle, so that the two rotate together. Typically the input force is applied to the outer edge of the wheel, and the output force is exerted on something, like a rope, attached to the outer edge of the axle. If the two forces are exerted in the same direction, then it is like a third-class lever. If the two are in the opposite direction, for example, a person pushing down on one side of the wheel while a rope is pulled up on the other side, then it is like a first-class lever. One may also have the input force exerted on the axle, in which case it is like a second-class lever. Both the lever and the wheel and axle are really torque, not force, multipliers. Recall that if the force is at right angles to the line from the axis of rotation to the point where the force is applied, then the torque is given by Fr.
What is the Kelvin temperature scale?
based on absolute zero being 0 K. A Kelvin, K, is equal to a degree on the Celsius scale. 0 degrees Celsius is equal to 273.15 kelvins.
How is antimatter used in medicine?
A three-dimensional image that shows biological activity in a person can be made using PET or positron emission tomography. PET uses a short-lived positron-emitting isotope, typically 11C, 13N, 15O, or 18F. The isotope is chemically attached to a molecule that is involved in the activity that is to be studied. Fluid containing that molecule is injected into the person, and after enough time passes for the molecule to reach its target, the person is put into the PET machine. The positron that is emitted by the decaying nucleus strikes an electron and decays into two gammas that are simultaneously emitted back to back, that is, 180 degrees apart. Detectors record the arrival of the two gammas, and computers extrapolate them back to the location of the gamma emission. When a sufficient number of events are recorded, a three-dimensional image of the region where the biologically active molecule accumulated can be made. PET scans can be combined with CT or MRI scans to pair information on the anatomy with biological activity for diagnostic purposes.
What is the difference between cones and rods?
Cones are cone-shaped nerve cells on the retina that can distinguish fine details in images. They are located predominantly around the center of the retina called the fovea. The cones are also responsible for color vision. Some cones respond to blue light, being most sensitive to 440 nanometer wavelengths. A second kind has peak sensitivity in the green, 530 nanometer light. The third is sensitive to a wide band of wavelengths from cyan through red. Its sensitivity peaks in the yellow, 560 nanometers. As the distance grows from the fovea, rod-shaped nerve cells replace the cones. The rods are responsible for a general image over a large area, but not fine details. This explains why we look at objects straight on when examining something carefully. The image will be focused around the fovea, where the majority of cones pick up the fine details of the image. The rods, being much more sensitive in low light levels, are used a lot for night vision.
What is a decibel, dB?
Unit of relative intensity of sound.
Where in the world does lightning occur most frequently?
Satellite lightning detectors show that over the entire Earth lightning strikes about 45 times each second, or 1.5 billion strikes each year. In the eastern region of the Democratic Republic of the Congo in Africa, every year each square mile, on average, has some 200 lightning strikes. A section of Florida known as Lightning Alley is a 60-mile wide hotspot of lightning activity in the United States. On average, there are 50 lightning strikes in each square mile per year.
Who demonstrated that electromagnetic waves exist?
Heinrich Hertz, 1857 to 1894, was a German physicist who was the first person to demonstrate that electromagnetic waves existed. He designed a transmitter and receiver that produced waves with a 4-meter wavelength. He used standing waves to measure their wavelength. He showed that they could be reflected, refracted, polarized, and could produce interference. It was Hertz's breakthroughs in electromagnetic waves that paved the way for the development of radio. In 1930, Hertz was honored by having the unit of frequency, which was cycles per second, replaced by the hertz.
What is the second law of thermodynamics?
It is impossible to convert heat completely into work in a cyclic heat engine. There is always some heat output. Also, heat doesn't flow from cold to hot without work input.
Does voltage shock you?
Signs around power plants and breaker boxes often state, "Caution, high voltage area." It is not voltage that can hurt you, it is the electrical current that flows through your body that can produce serious and sometimes fatal consequences. The Van de Graaff generator creates hundreds of thousands of volts, but produces such a low amount of current that the sparks it emits only cause muscles to tingle.
What is tension force?
Force that pulls an object apart. See tensile strength.
What are secondary colors?
Cyan, magenta, and yellow of light, blue, green, and red of pigments.
How do blimps remain at a chosen altitude?
A blimp is a non-rigid airship that floats in the air solely due to the buoyant gas within the giant balloon-like bag. It typically carries over 5,000 cubic meters of helium at a density about 7 times less than air. An airship floats in the air in the same manner as a ship floating in water. The weight of the airship must equal the buoyant force of the gas inside the bag. In order to increase the altitude of the blimp, the pilot increases its buoyancy by adding gas from pressurized tanks to the blimp, which expands the flotation bladders, displacing the heavier air and increasing the buoyant force until the reduced weight of the blimp equals the reduced weight of the air. To lower the airship, the buoyancy is decreased by releasing gas from the flotation bladders, which then decrease in size, displacing less of the heavier air. Because helium is a safer gas than hydrogen, it is what is used in today's blimps.
What is a converging lens?
Has at least one convex side. Its shape causes the entering light rays to converge, that is, come closer together.
What is quantum teleportation and how does it use entanglement?
First, what it is not. It is not beam me up, Scotty, where a person disappears at one place and appears at another. It involves only information transfer by either photons or atoms. Teleportation involves an atom whose state is to be communicated from a sender, Alice, to a receiver, Bob. It also involves a source of two entangled photons. Alice first sets or measures the state of the atom. This is the information she will send to Bob. At the same time she measures the polarization of one of the two photons. This polarization information is the encryption key that will allow Bob to decode the information. Because the two photons are entangled, the polarization of the transmitted photon is fixed. Bob now has the key that allows him to decode the information Alice sent. In practice, of course, the encryption key isn't the polarization of a single photon, but many. The longest distance information has been teleported is 16 kilometers through the air in Beijing.
What is ferromagnetic?
Iron, nickel, and cobalt. Unpaired electrons in large groups of atoms interact with each other so that they point in the same direction. Strongly attracted by magnetic fields.
What is atmospheric physics?
Study of the atmosphere of Earth and other planets, especially effects of global warming and climate change.
Who developed gears?
as early as 2600 B. CE in India and other parts of southern Asia, gears were used to open and close doors in temples and to lift water. Around 400 BCE, Aristotle, 384 to 322 BCE, described how gears were used. Archimedes described worm gears around 240 BCE. And in 40 BCE Vitruvius showed how gears could convert motion from a horizontal axle to a vertical one. In the 1300 CE gears were used in clocks in bell towers and on churches.
How large is the gravitational field at that altitude?
Its distance from Earth's center is about 6.7 x 106 m, so g equals 8.9 n/kg. That's not much different than at Earth's surface. The Moon is 384 x 106 m from the center of Earth. At that distance g equals 0.0027 n/kg. So the force of Earth's gravity on the same kilogram of meat would be only 0.003 of a Newton.
Did you ever see a piece of paper attracted to a charged rod, touch it, and then jump away? How would that happen?
If it touched the rod, it became charged with a charge like that of the rod. And so it would now be repelled. A conductor can also be charged after being polarized, but without touching the charged object. If you bring a large metal object, like a pie plate, near a charged rod, the positive charges will move to the far end of the plate. If you now touch this end briefly with your finger, the positive charges will be pushed even further away into your finger. When you remove your finger, the pie plate is negatively charged. This process is called charging by induction. Rubbing a glass rod with silk will achieve the same effect. The glass rod is positively charged, while the silk receives the excess negative electrons. The glass rod can still pick up small objects, but attracts the negative charges in those objects instead of the positive charges. When the pie plate is charged by induction, it will be positively charged.
What is impedance?
Opposition to wave motion exerted by a medium.
What is the difference between analog and digital signals?
All transmitters create what is called a carrier wave at a specific frequency. For licensed commercial broadcasters, the Federal Communications Commission, FCC, assigns the frequency. The carrier wave transmits no information. For information to be carried, some property of the carrier wave must be changed. The earliest methods of radio broadcasting used analog signals from a source like a microphone. Sound striking a microphone produces a varying voltage output. That is, the output of a microphone has the same shape of the amplitude of the sound wave that strikes it. The smooth graph below represents an analog signal from a microphone. To create a digital signal, the analog output of the microphone is converted into a series of numbers. For example, consider the graph above. Suppose the signal is sampled every 2000 times each second. That is, the voltage is recorded each 0.5 millisecond. The dots show the results of the sampling. Voltage can be in only whole numbers. The series of numbers representing the waveform would then be those shown in the table. Next, the voltages are converted into binary digits, a series of zeros and ones. The table on the right shows the conversion to binary for numbers 0 through 7. The binary digits reading left to right represent the numbers 4, 2, and 1. Thus 5 equals 4 plus 1 or 101. Now the binary numbers are converted into a series of voltages to be sent to the transmitter. One method is called pulse width modulation or PWM. A narrow pulse represents a 0, a wider pulse represents 1. For example, the first 4 samples would produce the following wave train. The receiver knows that 3 bits should be converted into a number. If the receiver is to convert the signal back to analog, then that number determines the amplitude of the analog wave.
What is a supersymmetry?
Proposed theory to solve difficulties with the Standard Model in which each boson has a supersymmetric fermion partner particle, or sparticle, and each fermion has a supersymmetric boson sparticle.
What is a permanent magnet?
Domains remain aligned after the polarizing magnetic field is removed, resulting in a permanent magnet.
What is speed, v?
Distance moved divided by the time needed to move, scalar.
Who predicted electromagnetic waves?
In 1861, James Clerk Maxwell, 1831 to 1879, demonstrated the mathematical relationship between oscillating electric and magnetic fields. In his treatise on electricity and magnetism, written in 1873, Maxwell described the nature of electric and magnetic fields using 4 differential equations, known to physicists today as Maxwell's equations. Putting the 4 equations together predicted the existence of the electromagnetic Wave. Maxwell was a professor at Cambridge University in England from 1871 until his death in 1879. He published other works on thermodynamics and the motion of matter as well. He also developed the kinetic theory of gases, and performed research in the field of color vision. Although Maxwell is not widely known to the lay audience, he is revered in the scientific community and rates in the pantheon of physics greats with Newton and Einstein.
What are the subfields of physics?
The word physics comes from the Greek physis, meaning nature. Aristotle, 384 to 322 BCE, wrote the first known book entitled Physics, which consisted of a set of 8 books that was a detailed study of motion and its causes. The ancient Greek title of the book is best translated as Natural Philosophy, or Writings about Nature. For that reason, those who studied the workings of nature were called natural philosophers. They were educated in philosophy and called themselves philosophers. One of the early modern textbooks that used physics in its title was published in 1732. It was not until the 1800s that those who studied physics were called physicists. In the 19th, 20th, and 21st centuries, physics has proven to be a very large and important field of study. Due to the huge breadth of physics, physicists today must concentrate their work in one or two of the subfields of physics. The most important of these fields are listed below. The Greek philosopher Aristotle wrote the first known book about physics. Quantum mechanics and relativity, both of these fields study the descriptions and explanations of the way small particles interact. Quantum physics, the motion of objects moving near the speed of light. Special relativity, and the causes and effects of gravity. General relativity. Elementary particles and fields, the study of the particles that are the basis of all matter. Both their properties and their interactions are included. Nuclear physics, the study of the properties of the nuclei of atoms and the protons and neutrons of which they are composed. Atomic and molecular physics, the study of single atoms and molecules that are made up of these atoms. Studies include interactions with each other and with light. Condensed matter physics, otherwise known as solid-state physics. Condensed matter is a study of the physical and electrical properties of solid materials. An exciting new study is that of nanomaterials, leading to nanotechnology. Electromagnetism and optics studies how electric and magnetic forces interact with matter. Light is a type of electromagnetic wave, and so is a part of electromagnetism. Thermodynamics and statistical mechanics studies how temperature affects matter and how heat is transferred. Thermodynamics deals with macroscopic objects. Statistical mechanics concerns the atomic and molecular motions of very large numbers of particles, including how they are affected by heat transfer. Mechanics deals with the effect of forces on the motion and energy of physical objects. Modern mechanics studies mostly involve fluids, fluid dynamics, and granular particles, like sand, as well as the motions of stars and galaxies. Plasma physics. Plasmas are composed of electrically charged atoms. Plasmas studied include those in fluorescent lamps, in large-screen televisions, in Earth's atmosphere, and in stars and material between stars. Plasma physicists are also working to create controlled nuclear fusion reactors to produce electricity. Physics education research investigates how people learn physics and how best to teach them. Applications of physics. Acoustics. Musical acoustics studies the ways musical instruments produce sounds. Applied acoustics includes the study of how concert halls can best be designed. Ultrasound acoustics uses sound to image the interior of metals, fluids, and the human body. Astrophysics studies how astronomical bodies, such as planets, stars, and galaxies, interact with one another. A subfield is cosmology, which investigates the formation of the universe, galaxies, and stars. Atmospheric physics studies the atmosphere of Earth and other planets. Today most activity involves the causes and effects of global warming and climate change. Biophysics studies the physical interactions of biological molecules and the use of physics in biology. Chemical physics investigates the physical causes of chemical reactions between atoms and molecules and how light can be used to understand and cause these reactions. Geophysics. Geophysics is the physics of Earth. It deals with the forces and energy found within Earth itself. Geophysicists study tectonic plates, earthquakes, volcanic activity, and oceanography. Medical physics investigates how physical processes can be used to produce images of the inside of humans, as well as the use of radiation and high-energy particles in treating diseases such as cancer.
What does a physicist do?
Physicists normally do their work in one of three ways. Some are theorists who create and extend theories, or explanations of the physical world. Others are experimenters, who develop experiments to test theories to explore uses of new instruments, or to investigate new materials. The third method of doing physics is to use computers to simulate experiments, explore and extend theories, or make observations that cannot be done by the human eye. Physicists can find employment in a variety of fields. Many research physicists work in environments where they perform basic research. These scientists typically work in research universities, government laboratories, and astronomical observatories. Physicists who find new ways to apply physics to engineering and technology are often employed by industrial laboratories. Physicists are also extremely valuable in areas such as computer science, economics and finance, medicine, communications, and publishing. Finally, Many physicists who love to see young people get excited about physics become teachers in elementary, middle, or high schools, or in colleges and universities.
What is a lepton?
Lightweight particles like electrons and neutrinos.
What was the first concert hall to be designed by an acoustical physicist?
Boston Symphony Hall, designed by physicist Wallace Clement Sabina, 1868 to 1919. Is the first concert hall designed specifically to enhance the sound of an orchestra. Sabina, who designed the hall in the late 1890s. Discovered the relationship between sound intensity, absorption, and reverberation time. Sound reflections can either enhance or ruin a sound. Sabina discovered that having strong reflections immediately after a sound was produced would enhance the acoustics. But if sound was reflected midway between the source and the listener, it would detract from the acoustics because the time of travel would be significantly different. Sabine's Boston Symphony Hall, built in 1900, established an excellent reputation for sound quality. Mostly due to the choices of sound absorption materials as well as the strategic placement of reflecting material. The goal was to use the sound reflecting materials, high % reflection ratios, to create strong initial reflections, while using sound absorbing materials, low % reflection ratios, to absorb most of the energy from sound that would ordinarily reflect off of the high ceiling and the side walls in the rear of the hall. In 1973, Mr. Avery Fisher contributed over $10 million to support a complete reconstruction of the hall, and the hall is now named after him. The changes improved the acoustics, but the large stage reduced the loudness of bass sounds and the initial reflections were still too strong. Curved surfaces on the stage made of extremely tight grain maple would have improved bass problem, and reflectors consisting of 30,000 dowel rods were installed on the side walls. Except for classical music concerts and opera, most performances use electronic amplification. Loudspeakers can be located throughout the hall, and their response to different frequencies can be adjusted to compensate for shortcomings in the hall. The signal to speakers far from the stage can be delayed, so sound from all speakers arrives at the same time. Further, these changes can be adjusted so that the hall has the best acoustics for any type of use.
What is physics?
Physics is the study of the structure of the natural world. It seeks to explain natural phenomena in terms of a comprehensive theoretical structure in mathematical form. Physics depends on accurate instrumentation, precise measurements, and the expression of results in mathematical terms. It describes and explains the motion of objects that are subject to forces. Physics forms the basis of chemistry, biology, geology, and astronomy. Although these sciences involve the study of systems much more complex than those that physicists study, the fundamental aspects are all based on physics. Physics is also applied to engineering and technology. Therefore, a knowledge of physics is vital in today's technical world. For these reasons, physics is often called the fundamental science.
What is opaque?
An object that allows no light through it.
What are streamlines?
Lines that represent the flow of a fluid around an object or through another fluid.
What is fission?
Form of radioactive decay where nucleus splits in two. Extra neutrons and a large amount of energy is released.
Why then, don't we see a violet sky?
Our eyes are most sensitive to colors in the midsection of the spectrum, about 550 nanometers. Because blue is closer to this wavelength, our eyes are more sensitive to it than indigo and violet.
What is a torsional wave?
Material is not only displaced vertically, but also twists in a wave-like fashion.
Did physicists recognize the military uses of fission?
Lisa Meitner had recognized that extra neutrons could produce a chain reaction that would produce a very large amount of energy. In early 1939, physicists from many countries attempted to create such chain reactions by slowing down the released neutrons. Among these were Enrico Fermi and a Hungarian-born physicist, Leo Szilard. They saw signs that such a reaction had occurred. In August 1939, Szilard drafted a letter to President Franklin D. Roosevelt, 1882 to 1945, that the German results could lead to an extremely powerful new weapon. To give his letter more weight, he convinced Einstein to sign the letter. It worked. Roosevelt directed the government to support fission research and created the Uranium Committee. While there were several important studies during the next 3 years, it was the British who made the breakthrough, finding that the rare isotope uranium-235 could be used in a weapon. The Americans were informed but ignored the results until a personal visit by one of the British team members convinced the Uranium Committee of the need for action. The United States then established a new office that could authorize large-scale engineering projects. Enriched in uranium-235 created a need for enrichment plants. One method chosen had been developed in California. Uranium metal would be evaporated in a vacuum. The atoms went through a narrow slit and then into a region with a strong magnetic field. Because of their mass difference, the two isotopes followed slightly different paths. The atoms condensed on the surfaces of separate containers. Dozens of giant machines, called calotrons, were built in a plant in Oak Ridge, Tennessee. Chosen because abundant electricity was available from the nearby hydroelectric plants. Not enough copper was available to wind the coils for the magnets, so 70,000 pounds of silver bullion were borrowed from the U.S. Treasury to be formed into wires for the machines. Somewhat enriched uranium from the calotrons was then combined with fluorine to produce the gas U6. Because of the mass difference of the two isotopes, 235 U6 would diffuse through porous membranes slightly faster, about 0.5%, than its more massive counterpart. Thousands of separations were needed to produce weapons-grade uranium, 85 to 90% 235U. The plant at Oak Ridge, built to accomplish this gaseous diffusion, had an area of 2 million square feet. Employed 12,000 workers, and cost the equivalent of $6.2 billion in 1999 dollars. At one time it consumed 17% of all the electricity produced in the United States, more than New York City.